So, good afternoon, everyone. Welcome to the live lecture 5. Good afternoon, everyone. So, welcome to the live lecture 5 for the NPTEL course Engineering Drawing and Computer Graphics. So, this course is being conducted by Professor Rajaram Lakkaraju from IIT Kharagpur and myself, Sanika. I'll be conducting this live session today. I'm doing PhD from Indian Institute of Science, Bangalore. So, in engineering drawing, it is always helpful when you can imagine or visualize the objects. So, whenever you are working, always keep this image in front of you. It gives you idea about both the first angle as well as the third angle projection. And from this figure, when you know that this is the first angle, this is the direction of the viewing, that is the observer direction. Then you have front view on this plane and you have top view on this plane, and accordingly, you can generate this view. So you have your front view here. By rotating this plane, you get top view below the front view. And when you are here, your right hand side view and left hand side view can be drawn accordingly. So when you are here, your left hand side view falls on the plane behind us, which is called the projection plane, which comes here. And similarly with third angle, with only this figure, you can again generate now you can again generate this one. So if you have this figure, you're also confident that which view will come where. Like in this case, the front view is here and the top view is below the front view. So so that's it. And then we'll go on to the last time's this thing I had given a match the following. And after doing this match the following, I'm going to go through the different projections of points and planes. And today I have a model which will help you to understand and imagine and visualize these projections of line and a plane, because what you have been taught is a very isolated and a simple case, and once it gets complicated, this model that I've made today for you will be help to imagine all these things. So I'll just quickly go through the last time's homework I had given. Not exactly homework, but exercise that I had given. So let us just see here. So I had this figure on the right, and you have to match the projections with the projections below. So these are the objects A, B, C, D, and 1, 2, 3, 4 are their respective projections. So now, if we see A projection, A and L are actually quite similar. So if you look at them in the side view, they will appear almost same. So A and L, the solution is A solution is 10 and L solution is this third. So the difference is in the side view. Here you can see that it is connected, whereas in A you will have a line here. So because of this and this plane are different. So A is 10 and L solution is 3. So if you have solved it, you can check your answers as I'm going through. So B and K, again B and K are quite similar. So here the top portion of B has been rotated like this and fixed. So again here they are almost identical in the top view. So you see B solution is 11 and K's solution is 9. So in top view, this and this, both the figures are same. So how do you decide which one is for B? So you will either need to check the top view or the front view. So one difference will be there in the side view, that once there'll be a hidden line and once there'll be a solid line, because when you're viewing from here, this plane is visible in B's case, whereas in K's case, the same line is will appear as a hidden line. So when choosing between D and K's solution, you need to be careful. So more clarifying view would be the front view, which you can see from here. So the more clarifying view will be which you can see from the front view. So B's solution is 11, where you can see that this portion is on the left side. Now when we go for C and uh-oh, when we go for C and F, I'll reduce this thickness little. So when we go for C and F, again you see that they are identical in top view, C and F. So if you see the top view, each one has a thing like this and uh, two rectangles on the top. So how do you again decide? So you again need a second view to ascertain the geometry. So similar to previous example, in side view, this line in this case, in C's case, will appear as a solid line, whereas in case of F, this line will appear as a hidden line. So that is how you can ascertain. Or the second way is to look at the front view, which is a more clearer way to ascertain whether it is C or F. So C's solution is 5. So here you can see the top view I had drawn already. In side view, this rectangle is on the left for C, and in case of F, in 12 you can see that the same rectangle is on the right. So that is how you can ascertain that whether it is for C or F. Now similarly D and H. So D solution is 6 and H solution is 2. So again in D and H, this top portion has been slid to the left. So guys, if you have any questions or you have any particular problems that you did not understand during the course, we can take them first and later on I can continue with what I have made, the presentation that I have made. Does anyone have any questions regarding the assignment or during the coursework, the lectures that have been covered in the last week? Okay, so you can type it out in the chat if you want.
Good afternoon, madam.
Good afternoon.
Ma'am, as I am attend, this is my first live lecture I am attending.
Okay.
So, madam, please can you just explain what is the purpose and what type of doubt query you can ask here?
So see, this live lecture has been introduced. Hi, please, yeah. So the live lecture has been introduced so that every week you can discuss any kind of doubts that you have related to the subject. So from my side, I'll be making a presentation to make you understand few of the things. And if you have some doubts of your own, I will try to answer them as well. So every week, every Saturday, I'll be conducting one lecture. Yeah,
Okay, okay. Thank you, ma'am.
yeah. So today I'm going to just quickly go through these things that I had given last time. So if you haven't seen it, all the links will be actually uploaded on YouTube. So you can look at the previous lectures there. So this I had given in last time's lecture. So those who have not seen this yet, before seeing this lecture, you can try to solve it on your own and then check with the answers, because these small exercises will help you in your imagination later, because when there are complicated objects you tend to get confused. So I'll just proceed with this for now. Um, so again here D and H, they have this portion has been slid here. So from top view itself you can make out whether it is D or H. So D is 6. So in here you have the small rectangle here, and for H case you have this part portion visible in the on the left side, and this L is same for both 2 and 6, this portion, the bottommost L shape. So, and I think this is the second last. Yeah, so E is very easy. You have this one rectangle here, and uh, oh, oh, and a structure like this at the bottom, and a rectangle over here. So E's solution is 1. Again G and J. So here this is as good as if you rotate this J here by 90 degrees, then G and J are mirror images of each other. So if you see G and J's solutions 4 and 7, you can see that this top view here and the top view here are exactly mirrored along this plane. So that way you can make out the differences between G and J. And ICF is also again similar. So I's solution is 8. So in top view you can see this one plane, the second plane, and this is the third plane. So 1, 2, and 3. And so I, C, and F. So you see, I and C are again mirror images of each other. Along, if you rotate I again by 90 degrees and have a plane here, I and C are mirror images. And C and F, this portion has been lifted, rotated like this, and fixed here to make F. So this way you can practice these simple objects. Okay. So now in the last week's lecture, you have gone through the projection of point and a line. So these are very simple and isolated cases that have been taught to make the things clear. So where will you use it actually? So let us consider the example of a square pyramid. Mm, yeah. So if are you able to see this?
Yes. Can you take it some closer? Yes, now it is.
Yeah.
Yes.
So this assume this is actually Eiffel Tower. So assume that this is a square pyramid. Okay. So if you say that when I'm describing this square pyramid, I can say that I am placing this pyramid such that I'm placing this pyramid such that one of the corners of this pyramid, this one of the corners of the pyramid is resting on the ground. It is resting on the horizontal plane. And then I say that this is, so I'll say that this is my vertical plane and this is my horizontal plane. Correct? Am I correct when I'm saying this is first angle projection? This will be my vertical plane and this will be my horizontal plane. So I'm saying that this corner is at 30 from the vertical plane. So that is where you require that point projection. Here you will use the point projection method. So how will it look? In front view, here I have it on the horizontal plane. The point is on the horizontal plane, let's say here, and 30 away from the vertical plane. So this distance will be 30. So when I see it in the projection, when I see it in the projection, where will I have it? I'll see the point here. In case of the front view, I'll see the point here, and in top view, I will see it 30 mm away here, like this. So that is where you actually have to use all these point projections to to ascertain a particular point in a more complicated object like a square pyramid, or you have a hexagonal plane, or you have a cube which is resting on some corner. So to mention that particular corner, they'll describe the point. So that is where you start drawing the rest of the projection, if it is mentioned. If it is not mentioned, then you can draw it arbitrarily just to have a better view of the object. So now I'll assume that this point is resting here, and I'll add another constraint that this plane, the base of the pyramid, is parallel to the vertical plane. So if you, what will you see on the vertical plane here? You will see a square like this. So you will be seeing a square like this. Am I correct? Am I right? If I have a square pyramid placed like this with the base parallel to the vertical plane, I will see a square like this. This view I'll see on the in the front view. So when you're drawing these lines, I'll show it with another color. When you're drawing these lines, it is actually saying that when you're looking at this. So now for you to able to be understand, I'll just rotate this here like this. Okay, so now my horizontal plane is like this and my vertical plane is here. So what I'm seeing is this line, this line, this line, and this line. So it is as good as saying that I have this line which is inclined to the horizontal plane but parallel to the vertical plane, which is similar to which case 1, 2, 3, or 4. It is similar to which case? So it will be similar to the third case which is shown in the figure here on the right side. Am I right? So I cannot see the chat at this moment. Okay, so you need to speak up. Okay, so this line is also inclined with the horizontal plane like this but parallel to vertical plane. Similarly, this line is this line, which is also inclined to the horizontal plane but parallel to vertical plane. So similarly, I can do this. Okay. Now, what I'm saying is I'll complicate it a little. Instead of saying that this base is parallel to VP, if I say that this base is rotated with respect to VP, like this, now what do you do? So let us just take a simple example here. So when you explain the line, when you try to imagine the line, you can always have a right angle, either the notebook or some pages or maybe a corner in the house, and you can imagine it as a pencil, which is your line. So now I'll say that this pencil is parallel to the vertical plane. Okay. So to explain the how the rotator, like if instead of the base of the pyramid being parallel to VP, if it is slightly tilted, I'll just go through this exercise. So in the end, you will be able to understand how I'm trying to imagine the lines which are also tilted with HP and VP. So just imagine that. Can you see the cardboard and the pencil thing that I've arranged here?
Yes, ma'am. Visible, visible.
Huh. So, okay, thank you. Yeah, so if this is the pencil and I'm saying that this line, which is my pencil, is parallel to the vertical plane, I can have it anyway. I can rotate it anyway in the plane, just that it should be parallel to the vertical plane. Now, if I give a second constraint that it is parallel to vertical plane and perpendicular to the horizontal plane, then I'll have it like this, which is similar to the first case that is shown here, which is here like this. This is the first case. Now that you've imagined the position of the pencil, then you can go more into the depth and ask or read the problem to check how much distance they have said that this line is from vertical plane and this line is from HP. So once you fix the position parallel to the vertical plane and perpendicular to HP, I'll say, let us say that from vertical plane, it is at 20 mm. So I'll place this pencil over here. Now still I have this motion. So to fix this motion, either they'll say that it is in the horizontal plane, like this point is in the horizontal plane, or this point is 50 mm above the horizontal plane. So this motion will also be restricted and I can fix it 20 mm from here and 50 mm from here. Let's go to the second case. Now again, I have this pencil which is parallel to the vertical plane, that is the line which is parallel to the vertical plane. I can always rotate it in all directions given that it is in the vertical plane. Now we'll give it a second constraint, that this pencil is also parallel to the horizontal plane. How can I fix this line? I cannot do it like this, I cannot do it like this, I'll have to keep it horizontal. Once you have the orientation correct, then you can go for the distance between the vertical plane and distance from the horizontal plane, whatever is given in the problem, and you can imagine it accordingly. And these things have been already covered, like how will you get the projection of this line here and this line here in the lecture. So I'm not going through it here, but this is how you can try to imagine it when you are given some problem. Now, third case. Again, we say that it is parallel to VP. Okay. And now instead of being it perpendicular or parallel, we have it that it is making an angle with horizontal plane. So this could have rotated like this. When it was parallel, I stopped it here. When it was perpendicular, I stopped it here. When they're saying there is an angle, some arbitrary angle, maybe 30 degrees, 45 degrees, 50 or 180, something, not 180, 160. So I'll have the pencil like this here, and I'll be able to see the angle between the horizontal plane and the line or the pencil in the vertical plane here, which is now my third case that has been covered in the lectures. Okay, so this is how you can try and imagine by yourself how your drawing is going to look. So this is how your pencil will look when you look from here. So in this plane, in the vertical plane, you will be able to see the true length. Okay, so when you have a pencil like this, assume that I am the vertical plane and this is the horizontal plane. So on this plane, you will see the true length of the pencil. And on this horizontal plane, if you look from the top here, if you look from the top, you can try to click a photograph with your phones, which has just one camera, so it does not see the effect of depth. So then you will see just this projection. If you project a line here from the horizontal plane, you will see this length in the horizontal plane and true length in the vertical plane. Now similarly, I can do this whole exercise considering that I'm given the pencil is in horizontal plane, it is parallel to the horizontal plane. One second. So let us repeat this exercise. I will I will I will unshare my screen for now so that this pencil thing is clearly visible in the bigger screen. Okay. So I can continue this whole exercise with considering that this pencil is in the horizontal plane now. Okay. So being in horizontal plane, it can now again be rotated all around. Again, I will add a constraint to this, that apart from being parallel to the horizontal plane, this line has to be parallel to the vertical plane. So again, the orientation is like this. Apart from being parallel to the horizontal plane, it is now perpendicular to the vertical plane. So this is always parallel in any angle. It is perpendicular when I am looking at like this. So in this plane, in the vertical plane, I'll see a dot, and in the top view, I'll be able to see the uh, true length of this pencil. Now, third case, like we considered for vertical plane, I'll say that it is now neither parallel nor perpendicular to the vertical plane, but while being parallel to the horizontal plane, it is at an angle to the vertical plane like this. So now what I'll be able to see, I'll see the projection in the vertical plane and true length in the horizontal plane here. Things will get complicated and interesting when I'll say that this pencil is now it is currently it is parallel to HP. I will make it at an angle to the VP. So this is this was parallel to VP, parallel to HP. I will give it some angle with respect to VP, and then I will also give it an angle with respect to the horizontal plane. Now, how do you imagine, how will you get the projections? So for that, I'll go back to the slides and also explain you this through the model that I have made. A small little model that I just made sitting in the room. Yeah. So are the slides visible again? Are the slides visible?
Yes, ma'am. It is visible.
So now in this case, when this was the case where it is parallel to HP, parallel to VP, I can see true lengths in VP as well as in HP. Exact length, the true length of this pencil is seen in VP as well as HP. When I rotate it with respect to VP, I see original length in HP and a projected length in VP. I'm giving another rotation with respect to HP. I'll rotate it like this. So now I have projection even in the horizontal plane and in the vertical plane. So I see the true length nowhere. Both the planes I'm able to see only the apparent length of this line. Okay. So So let us say that this is the horizontal plane and I have inclined this pencil with respect to the horizontal plane at 30 degrees, let's say. Okay, so what are all the points, all the not points, all the lines which will be at 30 degrees with respect to the horizontal plane? Can you imagine that this will be actually a cone I can trace here like this? See, a cone like this, and the angle between each line in this position, in this position, in this position is always 30 degrees with respect to the horizontal plane. And the special case of this is where I have it parallel to the vertical plane. And another special case is this where I have 30 degrees with the horizontal plane and parallel to the vertical plane. So in this case, only in this case, I'll see a true length in VP. In all other cases where my pencil is inclined at 30 degrees, either like this or like this, it's inclined at 30 degrees with the HP, and I rotate it here, anywhere here or anywhere here, I'll not see true length even in my vertical plane. So let us just try to imagine this thing with uh, this. Okay, so assume that instead of pencil now I have a thread here. So this thread is making, I think if you can see from this angle, it's making maybe 60 degrees. Can we assume it's making 60 degrees with the horizontal plane? Okay, now if I try to rotate it like I was rotating the pencil, I will try to rotate this thing here. Okay, so you can see that it is actually tracing a cone here. My center is fixed here. It is always making an angle of 60 degrees with the base. It is always making an angle of 60 degrees with the base, and I'm rotating it like this. So you can imagine that it will form a cone here. Am I right? So,
Yes, ma'am.
but, and when I'm saying that this line, instead of the thread, I had a pencil. When this pencil or this thread is parallel to VP, see, you cannot see it actually. I'll keep it here. So in this case, it is still making 60 degrees angle with horizontal plane. Okay, I haven't changed that, but it is parallel to VP now, which is this plane. So that is a special case that I showed you before. In all other cases, this point is still moving on this circle, the top of the cone. Okay, so the point I'm trying to make here is the point I'm trying to make here is wherever I go, in this case, the height of this point, this point, is always constant because I'm rotating along this top of the cone. Okay, this height is always constant. You remember that. And I think you'll be able to understand it also. So in this cone, I'm traversing along this line. So at every point, my vertical distance from the horizontal plane is what? The length of this pencil or this thread, and this is the theta. So what will be this? This is sine theta. So L sine theta, this height will always remain constant wherever I rotate this pencil. Here, wherever. Okay. So, and so let us now try to relate this with the projection, what projection we'll see in the vertical plane. So when you have it like this, okay. So now what is it? It is making an angle 60 degrees with the horizontal plane in this position. Okay. Now when I'm trying to rotate it like this, here it is, right now I have kept it parallel to the vertical plane. So I can see the true length in vertical plane. So let us just draw it. So this is the projection. Okay. Right now in this position, this is how the projection will look. This is the true length of my thread. And what if I look it from the top, I see the projected length, which is L cos 60. Okay. So this is this is L cos 60 for this case. Okay. Now let us see. I'll rotate. This thing has been going down for a little while. I'll just get it up. Okay. So now here it was like this. This line is parallel to the vertical plane. Okay. At this point, I'm getting the true length. Now let us see it from the top. What do you see? If I'm rotating it like this length, this projected length still remains constant in all the angles. So this is what I'll see in the top view. When I view from this side, this is what you will see. If I rotate the pencil like this, you will be tracing the circle. This is the circle that I am trying to show over here. This dotted line is the circle that you will see if I rotate this thing around the around this axis, keeping the angle with the horizontal plane, this angle constant, and I'm rotating this like this. So in top view I'll see a circle. Okay. So now when when this thread or the pencil was parallel to the vertical plane like this, it was just inclined to horizontal plane and parallel to the vertical plane. I was able to see the projection that I'm able to see in the slides right now. Once I start rotating this, once I start rotating this, now imagine in the top view, instead of having this line parallel to the VP, okay, it was like this. So I could see the projection of the line exactly like this, which is parallel to the VP. I'm sorry, which is parallel to this XY line, this XY line. Okay, now once I start rotating this like this, imagine that this line is also rotating here, 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 here. Are you able to imagine what I'm trying to say? So this this is the projection of this
Yes,
pencil.
ma'am.
What is rotating is the projection of this pencil, what I'm able to see. Okay, but like I mentioned before, this projection is now, this projection, the length of this projection should remain constant. Why? Because I've kept this angle with the horizontal plane constant. So if I'm rotating like this in this plane, in this plane, you have learned that you can rotate, you can have a vertical plane which is inclined to this original vertical plane, the auxiliary planes. Yeah, so if you can imagine a plane here like this, here, so in this plane you can see that this is again 60, this is again 60, so the projection will stay constant and it will rotate along this yellow circle that is shown in the slide. Okay, and at the same time, now this projection, now you can imagine actually that, let us say this was the original, this is the original pencil, it has got projected here in the horizontal plane. This is the projection, projected length, okay, which will actually trace the yellow circle. This black pen will trace the yellow circle, and this point will trace the top of the cone. Okay, so if we can imagine, I'm rotating these together. So this height always stays constant and this is getting rotated. So when you have this line rotating like this, so let us say I have rotated this by 60 degrees with respect to HP, and the second rotation now I'm giving 45 degrees with respect to VP. So I can imagine that if this is rotating, even my projection is rotating here. So let's say the projection has come over here, over here. Okay, in the slide, it has come over here. Now, instead of seeing the uh, true length in the VP, I can actually see a shorter length. But you cannot directly calculate it as actual length, uh, actual length का cos 45. Okay, that will be a even different length that you will see in the top view, in the front view when you are projecting it like this. Okay, so what I'll do, this will not be LSV. I'll again have a different front view where, and a top view where I'll consider just the projection of this line. Okay, so I'm considering this black pen, which is the projection, and instead of this I have rotated the projection at 45. Instead of the projection being parallel, I've rotated it by 45 degrees, and then I will project this distance in the top view. So what I've done, did you understand? I have rotated this thing. So I wanted to rotate this pencil, but in the air I cannot simply imagine what will be the projection on this vertical plane. So have it clear in mind that if you have the angle with horizontal plane, it will be always seen in the vertical plane. Can you see it in the horizontal plane? If you have angle with horizontal plane, you can never see it in horizontal plane, you will have to see it in the vertical plane. And similarly, if you have angle with the vertical plane, it will be seen in the opposite plane, that is the horizontal plane. So now, first when I drew it, I had angle with horizontal plane, here was the vertical plane. So I was able to see the angle with the horizontal plane. This was 60. In the vertical plane, this is VP and this is HP. Okay, I was able to see the 60 degrees angle in the vertical plane, and in HP I was able to see the projection. Now what I'm trying to do is I'm trying to rotate this thing by 45 degrees here. So with respect to the VP, where can I see this angle with respect to VP? I can only see it in the horizontal plane here. So by saying that I am rotating the projection, I'm actually rotating the pencil. But when I'm seeing from the top, since it is already at an angle with the horizontal plane, when I see from the top, I can only see the projected length. So that's why I'm saying that I'm rotating the projected length by 45 degrees here. So when I see from the top, I'll see this line at 45 degrees like I have shown here. Okay. So I have rotated, this is 60 and I have rotated by 45. Now I'm trying to project it on the vertical plane. Okay, so what I'll try to do is I'll get this on the top. Here I'll project this distance on the top. So what I'm doing, when I'm drawing straight lines, dotted lines in the slide, what I'm actually doing is I had it like this, I rotated it like this. Now let us consider this projected length. I'm putting dotted lines like this from this point and from this point, and I'm projecting it like this on the vertical plane for you to see in the front view. Because when I actually draw it, these lines, this plane is going to drop down like this, correct? So these vertical lines will come down like this. So I'm projecting these two lines here, or since this is at 45, I rotated this as 45, this plane. Now I'm rotating this plane like this. Okay, I'm rotating this plane like this just to have it on our paper, because we cannot have 3D on our paper. So I had it like this. I rotated it like this, and now I'm projecting this length here, so that the same thing I'm doing. Okay, here I projected it here on VP. Now to imagine it on the page, I'm saying that I rotate this HP here, and like I did it here, after I rotated it here, I'll have these sketch lines on the VP. So those are the sketch lines that I've drawn here. These ones, these ones, these ones. Okay. So now what I have is I have kept this, I did this, and I have the projected length in the uh no no whatever length this is, this length, this length is the projected length in the vertical plane. See, initially I had this projected length, I had this line at 60 degrees with the horizontal plane. This was my projected length. Now I have rotated this thing like this at 45. So even this line, this projection is getting again projected on the vertical plane. So that's why when I'm drawing these, this is the projected length on the vertical plane. But you see, if you see it like this still has some angle. So our line in the vertical plane is not going to look horizontal. Otherwise, what it should have been, a simple line which is here like this and rotated like this. So at the current stage, when I'm saying that this is at 45, and if I say that this is my line, it will be just like this, just angle with the VP. But it still has angle with HP, right? I did not put it down like this. I have it like this and then I rotated it. So now here comes that thing where you need to understand that when I have it like this here, and I rotate it with respect to VP, what I see here is that this point, the height of this point always stays constant, but the angle that we see with respect to VP, that changes. Okay, so this height, okay, this height that we were able to see, this height of the pencil when it was parallel to VP is staying constant because the line is still rotating on the cone. I have not changed the angle with HP. I'm just rotating it. So height remains constant. So whatever I do, I have another uh, point here that this and this point are still here. But instead of this line, wait, I'll see again change the color to something else. Let's take red. Yeah, so instead of this line being here, I now have it rotated at 45. So this point and this point, the origin and end of my pencil are still in the same plane, this plane and this plane. But what has changed? This position changed. Okay, so instead of here, now it has come here. So if I draw a line there and just insert a line, so if I try to project a line from this point, okay, if I try to project a line from this point, which is the which is my rotated projected length, okay, this point I marked is after rotating the projected length, right? So this will come here. So this is what separately I've drawn here. This inclined line is this one, and I'm projecting this height of the cone. This height here, and I'll draw a line like this. So this will be the actual length of line that I can see in the vertical plane. Instead of true length, I'll see this rotated thing. So this thing is similar to what maybe you have drawn in that uh, acceleration diagrams, like pendulum or what all those motions which move with a sine theta. You always draw a circle and explain it that okay, if it has moved by this theta, the actual position will correspond to this. If it has moved by this theta, the position will correspond to this. That is the same thing that we are doing here. Okay, so you actually see a lesser length here. All right. Okay, so I hope I'm clear. So when you also try it, you also try to imagine it like this. When you try to solve the problems, you also try to take a pencil here and whatever they give. So here what we did, we rotated it with respect to HP and then rotated with respect to VP. Now you see, one more point I want to make is here, initially you were able to see the angle with respect to the horizontal plane. This is the vertical plane. Initially you were able to see the exact angle 60. But after you rotated it with 45, only here you can see the 45 degrees. But the angle that you see here is different. Why? Because first you had this true length. Okay, this was the true length of your pencil, this side. When you rotated it, imagine you are rotating it along this cone here. Along this cone here, you are rotating this point. So my height, this height was constant. So I rotated it here. Now I have a different right angle triangle, which is like this, which is like this here. Okay. So my height stayed constant, but uh, this length, the apparent length that I see in the front view was different. So you can see that this angle which I've marked with blue is not 60, it is more than 60. So when you do this, when you first rotate it in with respect to horizontal plane, and then you rotate it with respect to the vertical plane. In the vertical plane, you do not see the actual angle with the horizontal plane. This is not the actual angle. If you measure this and say that actual angle with this is 70 degrees, it's wrong. What you can only say with confidence is that the angle with the vertical plane is 45. Okay, so similarly, now instead of rotating it first with respect to HP, and understand one thing that let's say that I rotated this with 60 and then with 45. Remember, 60 with horizontal plane, 45 with vertical plane. If I do the same thing, saying that pencil is here, I'm rotating it first with 45. Okay, first with 45, and then uh, by 60 degrees here, I will actually come to the same position. You see, because will we come to the same position or will it be different? Can anyone think about this? Will it be same or different? If I first
Madam,
rotate it by 4, huh?
can you repeat your question?
See, first what I've done here is I rotated with respect to horizontal plane, okay? And then I rotated it with respect to the vertical plane by 45. Huh? Now what I'm doing is first I'll rotate it with respect to the vertical plane and then rotate it with respect to the horizontal plane. Angles are same. Horizontal 60, vertical 45. Horizontal 60, vertical 45. With vertical, instead of the angle will remain same, but instead of first going with respect to HP, I'll go with respect to 45 and then 60. Will I reach the same position or not? Doing this and this instead of this and then this.
One end is fixed, no?
Yes,
One end is
yes. This
one
is
end,
fixed. This is
and we are
fixed.
rotating by same angle.
Yes, 45, yeah, 60 with respect to this and 45 with this. Instead of that, I'll now do 45 and then 60. Will we reach the same point? This point?
No, no.
Why?
Angles are different because first we are rotating with 45 degree, then 60 degree.
But here also, I rotated with 60 with respect to HP.
Yeah, ma'am.
Here with VP, I'm after rotating with 60, I'm rotating by 45.
Yes.
Keeping the point same, first I'll do 45 only. Here also I did 45. I'll again do 45 and then go 60.
Yes. Yes. Then we can reach to same position.
So point is same, but when we project it, when we try to project it, it will be little different. Okay, so don't get confused. You will always reach the same point. But first, if you rotate, I'll just copy this slide and show it how you can go the other way around. Okay, this is still not getting cut. Huh. So instead of doing it like this, if I go 45 first with respect to vertical plane, angle with respect to vertical plane will be seen in horizontal plane, that is top view. Okay, so instead of this, I will have, now please excuse me for the crude drawings. I hope you can imagine what I'm actually trying to say. I'm going 45 like this. Okay, so my true length is visible in the top view in the horizontal plane, which is at अरे, okay, which is at 45 with respect to the horizontal. This is 45, and this is 45, and this is the true length visible in the top view. Okay, and the projected length L cos 45 will be visible in the L cos 45 will be visible in the front view, which I will be projecting here. That is what I have done. Projected the lines here and then rotated this plane like this. So the horizontal lines are coming out vertical to the vertical plane here. Okay, and now I'll rotate it like this. Okay, first I rotated it like this, and I'll rotate now with 60 degrees. The problem here is, again, so in this case, now you cannot imagine that you have a cone in the horizontal plane. Now what you need to imagine is you have a cone in vertical plane like this. So you have to rotate this pencil like this. So I will keep this thing like this now, because I rotated it by 45. This line I've rotated it by 45. This angle is 45 now. Okay, so I've rotated it by 45 with respect to VP, and now I need to imagine that I'm drawing a cone like this, whose axis is horizontal, that is perpendicular to the vertical plane. Okay, and then now, again, now if you see in the vertical plane, you will see that I need to rotate this projected length. So in previous case, I rotated the projected length here in the horizontal plane and saw it that okay, I move it by 45, and then I project it in the vertical plane and see how the line actually looks in vertical plane. Okay, now I'm already rotating it by 45. So this is the cone, and I will be seeing the projection in this plane. And when I'm rotating this in the horizontal plane like this, with respect to the horizontal plane like this here, I'll see it in the vertical plane. And what I'll be actually seeing rotating is the radius of this circle, which is the projection of this plane on the vertical plane. So, projection of this line in the vertical plane. So now, because the angle with respect to horizontal plane is seen in vertical plane. So here now I will have a circle like this. So if I rotate this thing, I will see it in the vertical plane. Am I correct? So now I am saying that I have rotated this by 60 degrees here, 60 degrees, and so this is my projected length in the vertical plane. But since it is also tilted with respect to I'm sorry, this is my projected length in the horizontal plane, because initially when it was like this, I was able to see the true length of the line here. But once I started rotating it here, I was able to see the apparent length. So the apparent length in the horizontal plane is, or rather, saying it as apparent length in the horizontal plane, yeah, correct, horizontal plane में इतना ही length दिखेगा, but the actual length that we see is uh, is according to this constant height, because again I have this cone and this height stays constant. Okay, this height stays constant always. This point, the distance from this point and this point will stay constant. And again, here, uh, this I had the original right angle triangle with true length here. Once I rotate it along this circle, I'll get this projection as this line. and the right angle triangle will become shorter and this angle will be more. So now in this case, first, in the previous case, you were able to see the 60 degrees here and the 45 degrees in the second view. Now here when I rotate it with respect to VP 45, you will see that first angle in the first view. When you go to the adjacent view, you will see the 60 degrees with respect to HP. So I I I won't say that you will be able to understand everything with what I am showing, but this is a way to imagine lines, because you will have something like a hexagon and you place it like this, so it will have a horizontal line here, it will have a vertical line here, a tilted line here. So in that case it becomes very difficult to trace all these things, so it is important that you understand these isolated conditions now itself, so it will make your life a lot easier. And in future, this is a straightforward way. I'm telling you that this is a line. Where's my pencil? Yeah. So this is a line. I'm rotating it by 45 and then by 60. Okay. So here, first since I rotated it by 45 here, I see the true length here, and then nowhere I can see the true length later once I rotate it by 60. In this view, I cannot see the true length at all. So when you are given problems, how will you be given? They'll say that the apparent angle. So see, like I said here, uh, here I have rotated by 60. So after rotation, this does not remain 45. It will be more than 45, let's say 55 degrees. After rotation, the apparent angle with respect to VP looks like 45. But is it the actual angle? I did not change the angle with VP. It is 45 only. I just rotated it like this. So in that case, you need to imagine all these things so that you don't get confused. So they will give you the apparent length in top view is this and the apparent angle is this. So from that you will be able to maybe construct this view. From this view you will get this view, and from this view you will have to come here and get the actual true length of the uh, line. So that is why I'm saying that this is the straightforward way. I'm telling you that this is 45 and this is 60 and this is the auxiliary length. They might give you other parameters, they'll directly give you the auxiliary length here, and you then all this knowledge will be very important, where you can see the actual angles and where you can see the auxiliary angles. So there are a lot of constructions, but if you understand this basic thing, those constructions you need not by heart them. You will be able to understand why you are projecting it from here and there, because they are, I agree, they are very confusing, and I guess they'll be taught in the next lectures. So yeah, I have already gone through all these things. Yes, so coming back to the original problem where we started, so I was saying that this thing rests on a point here. So first I assume that this base is parallel to VP. So it was a very simple case, the third case in the slide, that this line is simply inclined to the horizontal plane, inclined to the horizontal planes once it is like this, or once it is like this, once it was like this here, or like this here. So these make the four lines. The moment I say that it is also tilted with respect to VP, all the complications start. So whether it is, so now when I say it is tilted with respect to VP like this, okay. So all the cases, no one can teach you all the cases. So I'm saying that this this was now at an angle to this, and now I made it like this. Okay, so you need not worry. What you're doing is, this line got tilted by 45 like this, whatever this is, it will get tilted like this. So this plane which was like this got tilted like this. Okay, so that plane thing will come later. I'll try to explain that also in the next live lecture, but here you need to understand, if you have a line, you rotate, if you first rotate it with HP, you'll go like this in a cone. So you'll be actually rotating the projected length in the top view and get the projected length in the vertical plane. or you can have it first, make an angle with VP, then you have a cone like this, and then you rotate the projected length in the VP by 60 degrees, because we have taken the example of 60 here, so you rotate it by 60 here. So you basically rotate the projected length, and remember that the height, this height from the vertical plane, always it stays constant. This height is visible in top view. So you rotate this, you get the apparent length here, and from the before this, the top view that you had got this height, you extend those lines, you get this height, and you get the rotated projected length ka projected length, and you finally get how it looks in the vertical plane. Okay, so that is it for today. Do you have any questions, doubts from the assignment, or any doubts of your own?
Madam, we are trying to, you are trying to teach us about rotating line method. Na? This is rotating line method.
Not exactly rotating line, but like you will be told that the line is inclined with respect to HP by this angle, or it will be inclined to VP by this angle. That's what. So how do you imagine which view do you see, which line do you actually move by 45? It will help you with this visualization.
Okay, madam. Okay.
So I hope this visualization was helpful. When you try it on your own, you will understand it more. You had any doubt you wanted to ask?
No, madam. No, no, no doubt.
Okay. Anyone else who has any doubt from the assignment or from the next lecture, if you want me to also go through the assignment questions, not this year's assignment questions, but similar problems. Okay, so please let me know whatever you are expecting from this live lecture also, because as the lectures are progressing, the difficulty level will increase. So we are also taking idea about what you want and what we are delivering. It should match both the expectations, right? So if you have any comments that we want this to be included in the live lectures, please let us know. Either comment on the YouTube links that I'll be uploading, or you can comment in the group discussion session, that group discussion forum in NPTL. Okay.
Madam, if
Huh.
spare a few minutes, maybe 10 minutes for our assignment, just previous assignment. That will be it's better good for us to understand something.
You have any doubts in the previous assignment? See, we are not actually allowed to discuss the current assignments. Okay.
Okay, madam.
I can discuss the last week assignments that you have already submitted. So if you have any doubts, you can ask it now.
Okay, okay. No, still, right now I don't have any doubt. Okay.
Huh. So you can ask, but we cannot discuss the current assignment. I can discuss the previous assignment. All right. Okay. So I hope I could explain or make imagination easy at least a little bit. So we'll meet next Saturday. So there'll be another lecture on Tuesday evening, which will be conducted by another PhD student. Uh, Timings you can see on your portal. Anyone else who has attended those lectures can please tell the timing. I think it's 6 or 7 maybe in the evening. Okay, fine. I think you anyway get the notification for joining these lectures, right?
Yes, sir. We are getting notification.
Huh. Okay,
Yes.
so for those who are not able to attend the lecture at this given time, you can also watch it on YouTube. I'll be uploading the video link as soon as possible. And the link I think is shared with you, and this presentation is also I think shared with you. So let me know if you have any further doubts. Okay. So, goodbye. Have a nice day.